Hi, Chem 1 students. I'm going to go over question 4 from the limiting and excess reactant worksheet. So as you know, we've been doing limiting and excess reactants. The limiting reactant is the reactant that's all used up. The excess reactant, not all is used up. We use some of it, and then there's some left over. All right, so let's do this problem. Starting with A, it says balance the following equation. So I have two ends here. Okay, I need to put a 2 here to balance the ends. That 2 will make times the 3 h's here. That makes 6 h's. So I need a 3 here. And then we have 2 ends, so I can put a 1 here to balance up. Okay, so we have our balanced reaction, which gives us the mole ratios. All right, in part B, it says if 35 grams of N2 are reacted with 12 grams of hydrogen, what is the limiting reactant and what is the excess reactant? Show your work. So what I'm going to do is do two mass to mass problems. I'm going to first figure out how many grams of NH3, okay, that I can make with my N2. And then I will do the same thing. I'll find how much NH3 I can make with the 12 grams of hydrogen. All right, so we need some molar masses. Okay, so I'm going to find my molar mass of NH3. So that's 14.01 plus 1.01 for hydrogen times 3. And we get 17.04 grams per mole. All right, my N2, my molar mass for N2, I'm going to take 14.01 times 2. I have 28.02 grams per mole. All right, my hydrogen is H2. So that will be 1.01 times 2 is 2.02 grams per mole. Okay, so I've got my information that I need to set up my mass to mass problems. So let me first start off with the N2. So 35 grams of N2. I'm going to figure out my amount of NH3 I can make with 35 grams of N2. I'll set up my conversion here. So first, grams of N2, we need to change to moles of N2 using the molar mass of N2, which is 28.02 grams. Okay, next step, the mole ratio. I am going to NH3. I need that amount on top here for my mole ratio. The ratio is 2, and we are starting from N2, so 2 to 1. Finally, we need to change to grams of NH3 using the molar mass of NH3, which is 17.04. So that goes on top and 1 mole on the bottom. Okay, so I'm now going to calculate how much this is. So I will put in 35. Okay, I will divide by 28.02 because it's on the bottom, times 2 because it's on the top, and then times 17.04, and I will get 42.569, but I got to round to 2 sig figs here. So this is going to be 43 grams of NH3. Okay, and that is from N2. Okay, from 35 grams of N2. Let's do the same mass to mass conversion with our 12 grams of hydrogen. So 12 grams of hydrogen. Let me set up my conversions here. Okay, we've got hydrogen first. I need to change to moles of hydrogen by using the molar mass of hydrogen, which is 2.02. Okay, next I need my mole ratio of my NH3, okay, to the hydrogen. So that's 2 to 3. And then finally, this is going to stay exactly the same because we need grams of NH3. So I'll use the molar mass of NH3 again. Okay, and now I'm going to calculate this. So I'll take 12 divided by 2.02, okay, times 2 divided by 3 times 17.04. And when I put this in my calculator, I get 67.48 but I'm going to round to 2 sig figs from here. So this will be 67 grams of NH3 from my H2. Okay, so which one is the limiting reactant? Well, I can see right here, this amount of NH3 is smaller. Our limiting reactant will give us the smaller amount of product. So my N2, I will label that as my limiting reactant. Okay, I'm just going to call it LR. Okay, that's my abbreviation for limiting reactant. And then my H2 will be the excess. Okay, there's no way we can make this amount because this N2 will run out, right? As soon as we get to this amount, the N2 is gone. Okay, there's 0 left. So we don't use all of the H2. It's going to be excess. There's going to be some left over. Okay. So now part C is really easy because we've set it all up here. We've done all the work for part C right up here. So we can just say, okay, our smaller amount of NH3 is what's produced. So we can just write down here 43 grams of NH3 are produced. Okay, the smaller amount. All right, moving on to part D. So part D, we have the question, how many grams of the excess reactant are used up? So I need to go back up here and see that my excess, okay, I'm going to write this down, is my H2. So because it's excess, not all of the 12 grams, remember, we started out with 12 grams of H2. Okay, not all of that will be used up because it's the excess, right? There's still gonna be some left over after the reaction is done. So we have to figure out how much is actually used up by starting with the limiting reactant. Our limiting reactant, okay, is our 35 grams of N2. So we want to start with, okay, our limiting reactant, okay, and then find how much excess is used. Okay, and in this case, the excess is the H2. So we are going to figure out how much H2 is used by the limiting reactant. So let's go back up and we have 35 grams of N2 as our limiting reactant. So we're going to start with this 35 grams N2. And we are going to go to our grams of H2 used. We're going to figure out, okay, if I have 35 grams of N2, how much H2 is needed to use that all up? So again, I'm going to have to set up a 3-step conversion going from mass to mass. Okay, so I need to first start off by changing my N2 to moles by using my molar mass of N2. Now, fortunately, we've already done all this work, so I just need to go back up and find my molar mass. Okay, so my molar mass is 28.02. So I can go and put that down here. Okay. Now remember our X, okay, what we're trying to find is our H2. So here in our mole ratio, I need to look at my balanced reaction. My balanced reaction, I'll write it here so that we don't need to scroll up, is 1 N2 plus 3 H2 yields 2 NH3. So I'm trying to find the H2 used by the N2. So I need my mole ratio of H2 to N2. So that's going to be 3 H2 for every 1 N2. And then finally, I will change to grams of H2. Okay, my molar mass of H2 is 2.02 grams for 1 mole. All right, and I'm going to plug this into my calculator and figure out how much H2 has been used by the limiting reactant. So I'll put in 35. Okay, then I will divide by 28.02. Okay, and then I will multiply by 3. Then I will multiply by 2.02. And that gives me 7.569, but I can only use 2 sig figs. So it's going to be 7.6, okay, grams of H2. Okay, so that's how much is used up. All right, so we figured out how many grams of the H2 are used up. Finally, all right, we're going to go on and we're going to find the grams of excess reactant left over. Okay, and this is the excess, our H2. So going back to the very beginning of the problem, we can look and see that we are starting with 12 grams of hydrogen. Okay, 12 grams H2 at the start. If we subtract, okay, what is used, okay, from part D, minus 7.6 grams used up, that will give us how much is left over. So when we subtract here 12 minus 7.6, okay, we're going to end up with 4.4 grams, okay, of H2. Now, technically, if we were going to follow our sig fig rules, okay, we'd have to have 0 decimal places. So technically, the answer is 4 grams of H2 would be the answer. Okay, and this is what is left over at the end of the reaction. All right, so we've gone through a whole limiting reactant problem with mass, okay, starting with 2 reactant masses. We figured out how much NH3, okay, how much product we could make from each of those reactants by doing 2 separate mass problems. The smaller amount is what is actually made. Then, when asked for the amount of excess reactant used up, we took our limiting reactant and we figured out how much of the excess, okay, is needed to use up that limiting reactant, and we got that amount. And then finally, to figure out how much was left over, we subtracted from the amount that we started with, and we got the amount that was left over. Okay, students, I hope this video was helpful. If you still have questions, please ask in class when we go over these problems this week.